Okay, so got interrupted on that last video. So we're going to go ahead and pick up at number 8. I thought this was going to be part of the last one, but that's all right. We'll do it now. Okay, so this one's a little bit of a tricky problem here. Is we've got the sine of 2 theta. Now, again, we only actually have one identity available to us for the sine of 2 theta, and that is to use 2 sine theta cosine theta. And that is our identity for this portion alone. And then you have an additional sine theta equals cosine theta. Well, that's kind of a lot of information there. There's just a ton going on. So what I noticed, if you were to put it all together, you'd get 2 times the sine squared times the cosine is equal to the cosine. And that's what I want to find out when that's true. And that's kind of a strange looking curve. I don't really know what that even would look like. But, we're just going to trust our algebra. So one thing that we want to do is, and it doesn't work 100% of the time, but I would say 95, you set it equal to 0, and then you look for that greatest common factor. So what I notice between these two, there's a cosine in common, and I'm left with 2 sine squareds minus 1. Now, as such, because I have that, then I either want the cosine of theta to be 0, or I want the sine squared of theta to be 1/2. Now, that's a little bit interesting because we haven't seen that before. But it is actually a good one to notice. Now, when the cosine of 0 is fairly straightforward, that happens at 1 and 3 pi over 2. Remember, that's just unit circle. The cosine is the x value, and the x value is 0, straight up and straight down. If you stop and think through that, straight up and straight down, the x value would be 0. But this is the one I wanted to focus on. When I go to take the square root of both sides, we always get that plus or minus. But of course, if you take the square root of the top and the square root of the bottom, you get that, which we have done quite a few times. And we have to fix that and make it root 2 over 2 because you have to multiply the top and bottom to rationalize the denominator. Well, that's interesting because the sine is root 2 over 2 at pi over 4. But I don't want just the positives, I want the negatives as well. So I want both positives and both negatives. So as it turns out, this particular problem actually has, it looks like 1, 2, 3, 4, 5, 6 answers. Now, again, like I said, I'd really like us to check our answers. So if we came in here and just typed in, let's see, the sine of 2x times the sine of x. Let me go ahead and delete all this other stuff. Sine of x. And I want to know when is that equal to the cosine of x. Now, window-wise, we just said, let's go ahead and find out from 0 to 2 pi. And some of you have been asking why only 0 to 2 pi. Well, remember, if we go ahead and let this thing go on and on and on and on, let's go ahead and let it go for maybe -2 to 2, because sine waves only go up and down between 1 and -1. But, this is what the graph looks like. It's a weird looking graph, but it's going to do this for all eternity. And so if we have that, I mean, sure, I could find all of the answers, but the reality is because it is a periodic function, if I just find the first 0 to 2 pi, that's the first cycle around the axis. Everything else is just going to be a repeat of that. And that's going to be a little bit easier to focus on. And so you can see that I have 1, 2, 3, 4, 5, 6 answers. And we can always check those answers a little bit by asking questions like, hey, I found one of my answers to be pi over 6. And notice, oh, excuse me, no, I didn't. It was pi over 4, just kidding. I'm going to calculate the value at pi over 4. And there you go. There's one of my answers. Now, the next answer over here looks like it's probably pi over 2. And there it is. And then the next one is 3 pi over 4. And so you could go through and you could check all those answers and make sure that they actually work. Now, this actually works well to have my calculator out because the next two questions are literally just supposed to be calculator-based questions. So all I wanted you to do is be able to recognize that sometimes you really have to use a calculator to get an answer, because that's just sort of what we need at times. Now, this one actually we could have solved without one, I think. Actually, no, I couldn't, because this would be where 5 cosines of theta is equal to 4, or when the cosine is 4/5. That's not going to be a very nice number. So again, we're just going to go 0 to 2 pi. And because of the height on this thing, I'm just going to go ahead and let it go up and down between -5 and 5. And I want to find out when those cross. So here comes my cosine. And there comes that one. And I have two different values here and here. So I'm going to calculate the intersection, moving the cursor kind of close. And so one of my answers is 0.6435, 0.6435. Now, what I can tell you is my other answer is going to be 2 pi minus that guy, or 5.6397. But if you didn't catch that there's that symmetry in that graph coming right off of those edges, you could do the intersection again. You just have to take the time to sit here and let your cursor get close enough to that other one to hit your enter 3 times. And I think we're there now. Bing, bing, bing. And what do you know? I got 5.639. So over here, we have this guy, the same idea. We have 3 times the sine of 3x over 2 plus 2 is equal to 1. And again, we just want to see if we could find out the places where those cross. And we have these two places, and you're going to find those two places. And one of those places is equal to 2.321, and the other place is over here at 3.962. Now, on the test, I may ask you to do it in degrees. And of course, if I ask you to do that in degrees, this is going to be a little bit irritating to people when we first set this up, but remember, in degrees, it's not 0 to 2 pi, it's 0 to 360. And you'll notice it looks like the exact same graph. It's the exact same graph, slightly different representation. And so this answer is 227.019 degrees, or almost there. Boom, boom, boom. 132.981 degrees. So that would be the two valid answers that work for that. All right. Hopefully that was helpful to you. I'll see you back in class. Have a good one. Bye-bye.